So we have this result about turning a basis into a new basis by replacing a vector. That's called the exchange theorem. And I just wanted to show you a geometric example of why we would expect this to be true. So suppose that we're in some plane in a Euclidean space. So it could be R3, of course. To have a basis, all you need is two vectors that aren't parallel to each other, right? So what would it look like to have some other vector that is a linear combination of those two? So right, this one is playing the role of beta 1, this one is playing the role of beta 2, and this one is going to be V. Right, so V has it's pointing in the direction of beta 2 to some extent, and it's pointing in the direction of beta 3 to some extent, beta 1 to some extent. So V is really a linear combination of beta 1 and beta 2. Now if you throw out beta 2, you still have two vectors that aren't parallel to each other, and so this is still a basis. So what is special about why do we need this non-zero coefficient? So let's look at another example to see why that's important. Okay, so here's a plane, and again we're going to have our initial basis, beta 1 and beta 2. And this time for V, I'm going to choose this vector. Okay. Now, you can see that if we wrote down just V and beta 2, right, this is not a basis for this plane anymore because it doesn't span this plane, right? Because V and beta 2 are parallel, the span of the two will only be the line that goes through them, not the whole plane. And this happened because V is actually a multiple of beta 2, right? Plus 0 times beta 1. So the problem here is that we replaced one of our initial basis vectors. The initial basis vector we replaced is one that had a 0 coefficient. And that's what caused this problem. It allowed our replacement vector to sort of collapse down into a smaller space. So what we should have done is, instead of our new basis being V and B2, so instead of replacing B1, we should take V and B1. Right? C2 was the non-zero coefficient in this linear combination, so we have to use V to replace not beta 1 but beta 2, and that leaves us with V and B1. And yes, V and B1 do form a basis for this entire plane, as you can see. So that's really the importance of choosing a beta to replace where the coefficient isn't 0. If you replace a beta where the coefficient is 0, you get this sort of collapsing down thing, so that the span of after you do the replacement is smaller than it was before.